Good day everyone. On this video lesson of pre-calculus conic section, we will mainly focus on the conic section ellipse, focusing on the standard equation of an ellipse. Remember that there are two standard equations for the ellipse. The first one is the x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. This standard equation focuses mainly on the standard equation that has a horizontal major axis. And the second one is x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1 for a vertical ellipse with a vertical major axis. Okay, so let us try first on the given example, on easy part. What is the standard form of an equation of an ellipse with center at the origin, major axis on the x-axis, and a is equal to 6 and b is equal to 4. So remember, there are different properties or parts that are needed in the standard equation of an ellipse. So let us solve now for the standard equation. So remember that the center is at origin. And the coordinates for our center is given by C, H, K, where on this particular given, your H and K are 0, 0. Okay? And then, for the major axis, it is given by x-axis. And as we all know, if the major axis is x-axis, our ellipse is horizontal. And we have given that A is equal to 6 and your B is equal to 4. And for an ellipse that is horizontal, our standard equation is in the format of x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Your clue here that your major axis is horizontal. And if that is the case, we can use this format for a horizontal ellipse, and we can now put the values for our coordinates of the center and the value of our A and B. So if h is equal to 0 and k is equal to 0, our solution would be x minus 0 squared over a squared. Your a is equal to 6. So we have 6 squared plus y minus 0 squared over 4 squared is equal to 1. Then let us simplify. So your final answer would be equal to x squared, because x minus 0 is x squared over 6 squared, which is 36, plus y squared over 16 is equal to 1. So therefore, this is your standard equation of an ellipse with the center at 0, 0, with the major axis as your x-axis, and or on the x-axis, and a is equal to 6, b is equal to 4. Okay, example number 2, we have the given equation or given properties for the standard equation of an ellipse with still at the center at the origin, and your major axis this time is y-axis, is on the y-axis, and your a this time is 10 and your b is equal to 7. So remember, a is half of the major axis and b is half of your minor axis. Give you time to pause to solve for this before we show your solution. Again, the center at the origin, your major axis this time is on the y-axis, meaning that your clue there is the orientation of your y-axis. So, if the major axis is on the y-axis, it is a vertical ellipse. Okay? So, write again your given. First one is your center at 0, 0. Remember, this is your h and k. Your major axis, which is a vertical ellipse this time. Again, remember what is your vertical ellipse. Then, if your A is equal to 10 and your B is equal to 7, we write A is equal to 10, B is equal to 7. We can now write our equation. Okay? And vertical ellipse has an equation of x minus h squared over b squared this time plus y minus k squared over a squared is equal to 1. Substitute your given. We have x minus h, so it becomes x minus 0 squared over b squared, which is 7, squared plus y minus 0 squared over 10 squared is equal to 1. So x minus 0 is x squared, 7 squared is 49, then y minus 0 is y squared, then 10 squared is 100 is equal to 1. So therefore, this is your final answer for example number 2, easy part of our ellipse equation. Okay? So proceeding to number 3, let us have determine the standard format of the equation of an ellipse whose center is at 3, 4, whose major axis is horizontal, and b is equal to 8, c is equal to 15. Again, you can pause for a while before we show you our solution. Given that the center is at 3, 4 this time, it's not 0, 0 already, then it is given that, stated that your major axis is horizontal, and this time your b is equal to 8, c is equal to 15, the value of a is missing. Okay, so let us start first. What are the given values that we can use? Again, horizontal major axis, meaning our equation will be formatted in x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Okay, again, we have given such as your center, we have h and k, which is 3, 4, and then we have b and c. Okay, so for b and c, we need the value of a. If a is missing, we can use the Pythagorean identity that we have used from the previous video. So the Pythagorean identity is to get the value of a squared, which is equal to b squared plus c squared. Again, if a squared is missing, we can use the Pythagorean identity of b squared plus c squared, which is equal to 8 squared plus 15 squared. Okay, so 15 squared here for the value of c. And then, you can simplify the values that we have. Remember, you need to simplify first before you add. Still, follow the rules of the Pythagorean, the rule of PEMDAS. Okay? Parentheses, exponent, multiplication, division, and so on and so forth. Okay? So, 8 squared is equal to 64. 15 squared is equal to 225. And then you add them to 25 plus 64 is equal to 289. And if we get the square root of 289, because that's the value of a squared and you get the square root, a is equal to 17 units. Okay? You already have a, b, and the center coordinates, so we can now substitute the value on our given equation. It will be resulted into x minus, since 3 is positive, so you write x minus 3 squared over your a is 17 squared plus y minus 4 squared over your b is 8. So it is 8 squared is equal to 1. Then simplify the denominator so that it becomes a whole number without an exponent. So that is resulting to x minus 3 squared over 289 plus y minus 4 squared over 64 is equal to 1. And therefore, this is your standard equation for example number 3 with centers at 3 and 4, 3, 4, your major axis which is horizontal, and b is equal to 8, c is equal to 15. Okay, so proceeding to number 4 example, let us have Determine the standard form of the equation of an ellipse. This time, whose center is at -3, -4, whose major axis this time is a vertical major axis, and your A is 13, C is equal to 12. On this example, we have a vertical major axis, meaning we have to use the second option or second equation, and the value of B is, this time is missing. Okay? You can now pause for a while before we continue on showing or solving for our standard equation. Okay? So for this one, let us try this given ellipse at a major axis is a vertical one. Again, it is almost the same with example number 3, but this time your center is at -3, -4. Okay? Again, first write your equation. It is given x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Remember, this is a vertical ellipse because your major axis is a vertical one. Write your center. Again, your center is at -3, -4, so be careful on writing it inside your equation. And lastly, we need to solve for the value of b. Use the Pythagorean identity again. It's a squared is equal to b squared plus c squared. On number 3, the missing identity is your a. But this time your b is missing, so we need to write a squared is equal to b squared plus c squared. And then we can now solve by writing 13 squared is equal to b squared plus 12 squared. And if you simplify, 13 squared is equal to 169 is equal to b squared plus 12 squared, which is 144. Okay? And then, transpose 169 minus 144 is equal to b squared. And then 169 minus 144 is equal to 25. That is already your b squared. You can get the square root by the value of b by getting the square root, which is equal to 5, but I will use 25 already because I need that on my standard equation. We already have the value of your b squared and the value of your a squared, so we can now already write our equation. Again, it's x minus h, but this time your value of h is -3, so it will result to x minus -3. Pwede ka na pong pakidiretso na lang, and your b squared is 25 plus y minus -4 squared over a squared, which is 169 is equal to 1. And then, try to solve. So we will have x plus 3, or simplify rather. Simplify minus -3, then 25 plus y plus 4 squared over 169 is equal to 1. And this is already your final answer. Okay? So, that's for your average examples. Given on the first part, your EC is having at the origin, and this time the center at not on the origin, but rather we have +3 and 4 and -3, -4. Okay? So, we will now proceed to the difficult part of our example. Example number 5 for the next slide. For example number 5, on difficult part, we will determine the standard format of the given equation. This time, the given is the vertices of our major axis, 2, 0, and 2, 8. And the co-vertices at 0, 4, and 4, 4. First is, what is the orientation? What equation should be used on this particular example? And also, what is your center? Okay, so you can pause for a while before I show you, or we will show you our equation. Okay, again, before we solve, so let us review first the given values. So the values are the endpoints of the vertex, or rather the points of the vertices, which are 2, 0 and 2, 8. Remember that the vertex is the endpoints of your major axis. And as we all know, the length of the major axis is given by 2a units. Okay, again, this is the length or the distance between two vertices, while the co-vertices at 0, 4, and 4, 4 are or is used as the endpoints of our minor axis. And the minor axis is 2b units. Given this information, we can solve for the distance between 2 points by using the distance formula. Again, we can use this as our x sub 1 and our x sub 2, y sub 1 and y sub 2. If 2a is equal to the major axis, by using these two coordinates, we can have 2 minus 2 squared plus 0 minus 8 squared, which is equal to the square root of 2 minus 2 is equal to 0. So you will be having the remaining negative 0 minus 8 or negative 8 squared, which is equal to square root of 64. And that's the value of your 2a. And square root of 64 is equal to 8. And therefore, the length of the major axis is 8 units. But remember, we need the value of a, so you can divide both sides by 2. And a is equal to 4 units. So you already have the value of a. And on the other side, we will solve for the value of our b. Okay, so 2b for the minor axis, that is equal to the square root of, again, this is x sub 1, x sub 2, y sub 2, and y sub 1 and y sub 2. So 0 minus 4, so they are interchangeable, so you do not have any negative sign para diretso na kayo sa sagot. So we can have x sub 2 minus x sub 1, so it's the same. 4 minus 0 squared plus 4 minus 4 squared. Again, 4 minus 0 is square root of 4 squared plus 4 minus 4 is 0 squared. So, hindi ko na siya isusulat. So, we can see here that we can cancel out the radical sign and the squared symbol. So, cancel out. So, therefore, the value of your b or 2b or minor axis is 4 units. And then divide both sides by 2. We have the value of b, which is 2 units. Okay? But there are still missing parts or properties. And the last one is our center. Again, remember that the vertex V2 and V1, okay, is on what quadrant? Imagine or look for any graphing paper or graphing calculator. Later, I will flash a graph of the 2 or the 4 coordinates to show you our given equation. If it is a vertical or a horizontal ellipse. But before that, remember that the vertex V1 and V2 is the endpoints of your major axis. And the center of our ellipse is the middle part of the major axis. Given this information, we can use the value of our given by using the midpoint formula. Again, we can use the midpoint formula, which is center HK. So your H will be we will be using 2, 0 and 2, 8. So x sub 1 plus x sub 2 divided by 2 and y sub 1 plus y sub 2 divided by 2. So it will be resulting into 2 plus 2 divided by 2 and 0 plus 8 divided by 2. Simplifying, so 2 plus 2 is 4 over 2 and 8 over 2. So your center H and K are at the coordinates of 2, 4, positive. Okay, on the next slide, I will show you the graph and we will now use the following information of A is equal to 4, B is equal to 2, and the center at 2, 4 for the standard equation. As we can see on this graph, we already shown you the position of the vertices, which is on the upper part and lower part, and it is basically on our first quadrant. Again, by graphing, we can already show you the orientation of our ellipse, and it is a vertical ellipse. Therefore, we can now write our standard equation based on this graph, and it is in the format of x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Okay? So, we have shown you the coordinates of the center, and it is 2, 4, and your a is equal to 4 and your b is equal to 2. Just plug it in on your equation. If it is 2, 4, we will have x minus 2 squared over b squared, which is 2 squared, plus y minus 4 squared over a is equal to 4. So we have 4 squared also is equal to 1. And therefore, we can now simplify the denominators by squaring 2 and 4. And your final answer would be x minus 2 squared over 4 plus y minus 4 squared over 16 is equal to 1. And therefore, this is already your final answer. Okay? And lastly, on number 6, let us analyze the final example. So let us have determine the standard form of the equation of an ellipse with vertices, this time at -1, -1, and 9, 1. And we are given by the covertices at 4, 2, and 4, -4. So analyze first before we solve it. Okay, let us now try to solve for this example. So again, remember that the vertex or the vertices are your endpoints for your major axis. So if your major axis is being solved, so it is equal to 2a, and if it is 2a is equal to the square root of 9, we can use this as our x sub 2 and our x sub 1. So this time I will write 9 minus -1, so it becomes plus 1 squared plus -1 plus 1 squared. Then simplify, and that will result into 9 plus 1, that is 10 squared plus 0 squared, and you can see here we can already cancel out the radical sign and the squared of our 10. So cancel out, so that will result into 2a, which is equal to 10, and the value of a is equal to 5 units. If it is 5 units, we can now again solve for the length of our minor axis. So for the minor axis, it's equal to 2b, and it is equal to the square root of, this time this is my x sub 1 and x sub 2, so that we can have a fraction, rather than positive answer already, we have to use x sub 1 first instead of y sub 1. X sub 2 rather. So we have 4 minus 4 squared plus, I will write 2 this time, plus 4, so that it becomes positive, so that it is 0 squared plus 6 squared, and that is resulting into 6 squared. Cancel out the squared, and it will result into 2b, which is equal to 6, and divide both sides by 2, your value of b is equal to 3 units. Again, the center is missing. This time I will show you if we still use the vertex, or rather the co-vertices, it is still the same with the vertex. We will just use the midpoint formula. Okay? So let us use the midpoint formula. We have 4 plus 4 over 2 and 2 minus 4 over 2. So remember, why is it becoming minus 4? And then we have 8 over 2, the -2 over 2, final answer would be 4, comma, negative 1. And this is the coordinates of our center. On the next slide, we will show you the graph and we will try to find for the standard equation given the values of A, which is equal to 5, and B, which is equal to 3, and the coordinates of the center. Okay? The final part of our video presentation, we will be having your vertex at -1, -1, and 9, -1. And your covertex at 4, 2, and 4, -4. That is being graphed on the upper part of our video slide. Okay? So, again, this is a parabola. An ellipse rather, that is having your major axis, which is a horizontal one. So therefore, our ellipse or the given ellipse is given by a horizontal ellipse, and the standard equation of it is in the format of x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Remember, we already solved for the value of or the coordinates of the center, which is at 4, -1, and your a is equal to 5 and your b is equal to positive 3. So, substitute the value. Remember, the coordinates of the center is given on the graph on the upper part of our solution. Okay, that's 4, -1. And then, substitute. Since 4 is positive, so it becomes x minus 4 squared. Then 5 squared for a, and plus y minus -1 becomes positive 1, and your b squared becomes 3 squared is equal to 1. Simplifying, so your final answer would be x minus 4 squared over 25 plus y plus 1 squared over 9 is equal to 1. This is 9, and this is your final answer for the given equation of an ellipse that is a horizontal one. Okay, so that's all for this video presentation. May I remind you that in mathematics or in your lessons, not only on our subject, as said by Sir Benjamin Franklin, tell me and I forget, teach me and I may remember, but involve me and I learn. Always look for the things that you often mistaken on our solution, then change it, practice, and practice until you mastered the specific topic. So that's all for today, and see you on the next video.